Well, good afternoon. It is an honor and privilege to be here with you at Emberfest. My name is Jon Kilroy. I'm an architect at Verizon Media. And today I'm going to share my team's experience building apps in Ember in a modular way. But a little bit about me. I am JKUSA on the internet and Jon Kilroy on Twitter. And I've worked for the same company for quite a while. In 2007, I joined Yahoo. And a few years ago, we were bought by Verizon, and we call ourselves Verizon Media. And during the last 12 years, I've had different roles and responsibilities. I actually got my start as a data pipeline engineer, processing large data sets. Then I worked my way up the stack, building web services for advertising systems, and then started building Ember apps at the presentation layer. And now I work as an architect, building and designing full end-to-end data systems. I also have a side gig. I officiate weddings. This is my sister here. And while I've only done one wedding, I'm completely open this fall, so tell your friends. All right, how do we build apps? Well, I said we build data systems. So what is a data system? A data system is a process where we take a large data set and process it in a meaningful way so end users can take action on the data or find some kind of insights. And I'm just going to level set with a few terms. The first is a table. I think most people know what a table is. It's a collection of data, related data, in rows and columns. But there's this concept of a metric. And this is what is known as a measurement or a fact. And then a dimension, which categorizes or bucketizes that fact. So let's look at a table. It has a few columns and rows. On the far right, we have our metric column. This is a brick count. And then we can categorize it by its brick color, the type of brick it is, and the part number. These are all dimensions. And in general, we build data systems that look like this. We take raw events that come from thousands of servers, and we dump it on a grid of thousands of compute nodes. And we use some sort of MapReduce framework like Hadoop or some streaming service where we can process it, maybe do machine learning on it, and then boil it down to something that we can store in an analytics mart. And to expose that to the outside world, we throw a web service in front of it. If the data also has an identity or an ID, we usually store that into a different type of database, usually a NoSQL like HBase or maybe a relational database like MySQL. And we expose that through a framework that we call the LIDE. This allows us to generate a JSON API very quickly. It also supports GraphQL. You can actually do both at the same time, which is kind of neat. But then at the presentation layer, we build single-page applications in Ember.js, of course. And so I really want to focus on that Ember layer. This is a picture of the Tompster made by my daughter. She's 9 years old. I think she did a pretty good job. And I have to say that Ember over the years has really been there for us. We got our first production app out on Ember 1.2.0. That was like pre-Ember CLI. And yes, we had array controllers and Ember.bind. It was great. But that's all gone now, thankfully. We're now on that same app. Now in 2019, is on Ember 3.12. 3.12, hoping to get on 13 soon. And with Ember, we're able to build all kinds of great applications for our users. We have apps that expose analytic data for engagement, like number of page views and unique users, which devices come to our sites and properties. We have applications that report on advertiser campaign health, how many clicks and how many ad impressions they see. And if you're like my team, where you build a lot of Ember apps, maybe you're in consulting, maybe you're a freelancer, maybe you just built a number of apps, you start to see patterns. You see time and time again, you might need a calendar picker, right? You might need to add security. You probably should, right? Maybe you need to bring in a map visualization, right? And we see these patterns, and as developers, what do? We wrap them in libraries so that we can write the code once and use it over and over again in different applications. But there are larger patterns that we see. Either we develop or we see them out on the web. For instance, if you have an e-commerce site, right? You're probably going to have a checkout experience, right? Especially if you want to get paid. If you're doing CMS, you're going to have authoring tools. And if you're like my team, where you do analytics, your bread and butter There's going to be reports and dashboards and visualizations. Now I want to switch and talk about Lego. But first, the lawyers at my company really wanted me to tell you this. A little disclaimer here. This talk is not endorsed by Lego. This talk is not sponsored by Lego. I am not an employee of Lego. I have no connections with anyone at Lego. All images are owned by Lego, and I'm not being paid at all in Legos. If you're not familiar with Lego, for some reason, there's these small little plastic pieces, bricks, that compose all kinds of amazing structures. I myself was really into the space Legos back in the 80s and 90s. And I don't know if I'm the only one here, but I always like to test my Legos to see how strong they were. Like I would maybe punch it or drop it or twist it, see how strong it was, never with a flamethrower. And kind of what was alluded before, if you know a little bit about Lego, you know its home is right here in Denmark, right? But what you might not know is that Lego is short for the phrase, play well. And I know I'm not the only one to say this, but building an Ember app is kind of like building with Legos. And just like real Legos, Ember add-ons work well together. And if you haven't made the connection yet, Legos, Denmark, Emberfest, it all works together. It all fits. So when we build an Ember app, we usually get our routes, we get our secret sauce in there, but then we can pull from this amazing library of add-ons. If we need to do concurrency, we have Ember concurrency. If we need to validate, we bring in Ember CP validations. If we want to animate our views, we have Ember animated and Ember data for persistence, and so on and so on. And there's no doubt that using these small composable add-ons provides a lift to our productivity. But still, development is costly. We have UX and usability concerns. We have to wire up all these libraries and think about the interactions between them. We have styling. We have to test it all to make sure it works. This is for Mel. We have accessibility concerns, and we have internationalization and localization. And then once we build something, we have to go through feedback loops with our customers to make sure we're building the right product and experience. So what if we could extract these patterns that we see again and again, these larger patterns, these larger experiences, into larger building blocks? So I want to go back to Lego for a second, because it turns out that Lego has a larger brick, a larger piece. It's called the Duplo. I got some right here. So in 1969, Lego came out with the Duplo. It is a brick that's 2 times the height, width, and depth of your standard Lego brick. And it was to help small children handle the pieces well and prevent choking, because a lot of those pieces can be small. And with Ember, we can actually encapsulate large swaths of functionality into an add-on and maybe even prevent choking. So, can you see that? Where did it go? Okay, there. Oh man, let me start over. What? All right. Come on. What do I have to do to make it work? Oh, okay. Just pretend it started from the beginning. So when you build your Ember app, your experience, you build with routes and controllers and models and templates, components and services. But it turns out with Ember, we can actually bundle that all up into a single add-on. And so when we build applications, we can actually use these larger bricks with smaller, fewer amounts of moving pieces and get us to production much quicker. And then the idea here is that if we can encapsulate a large swath of functionality in an add-on, we can save on development costs because we're not doing it over and over again. We can collaborate across teams in open source, and we can reduce repetitive work. And so some of you right now are thinking, isn't this just engines? He's just talking about engines, right? And the short answer is no, not really. With Ember engines, you're typically setting out to build an app, usually a large app. And you break it down into smaller pieces so that independent teams can build these features and experiences, and then you can bring them back together to ship your app. And not only that these engines are actually in a little isolated container, so they're really hard for the application, the host application, to customize the engine. But with these Duplos, we are building foundational pieces that can be composed to build not just one app, but to several apps. And these two apps might not look the same. Not only that, but these Duplos can be customized to fit the needs of the individual application. Because as we know, each app is a snowflake, right? With its own requirements and its own stakeholders and its own special sauce. So what does this look like? What does this look like in practice? Well, let me tell you about one pattern my team has observed. Many times we go out and we build a dashboard for a specific use case, and we optimize it both for usability and for performance. And when we do, we ship it, and we give each other high fives. We say, great job, guys. We did it, and everyone's happy. But it's not long after we ship it that we get some stakeholder come by, like this businessman right here, and say, great job, guys. I love it, but I want more. I want another toggle here, and I want to add another little feature here, add another visualization, and on Tuesdays, change this line chart to a bar chart, and so on and so on. And we found that we had so many one-off requests that we just have a wall of control and one-offs. And this is really a sad story, because usually you lose the great experience that you had initially, that you initially set out to do. So we had so many one-offs that we said, we're going to build that 80% case for our customers, but for everything else, we're going to build a self-serve reporting experience. And we found that this was so common in all the applications that we built. We made a set of Duplos that allow us to have an ad hoc reporting system, a custom dashboard experience, a directory to manage all this data that users are creating, a set of alerts and an admin layer, and then some core add-ons that all these Duplos can share. And we open sourced it. You can check it out. It's called Nobby. It's on Yahoo/Nobby. And this is a quick demo. So here, we're going to select some metrics and dimension columns. You guys are experts now. And we can get it in a data table. We can change different visualizations from pie chart to bar chart. Here we're filtering to specific dimension values. Of course, we can customize our visualization. We can save it. And we can add it to a dashboard where we can curate a set of reports together. And so any user of this application can build their own report in their own dashboard and get their custom insights that they want. And when we first built this, it was really great because all the applications that wanted these features could simply just mount them into their Ember app. But what's really interesting now is that we find that when we build a new data application, we actually start with these Duplos. So we're already starting at the 50th floor. And so that kind of offloads pressure to build that custom experience and just expose the data to our customers. And what's great about this technique is that it allows app developers to have all this functionality out of the box, all the best practices that we've instilled into these packages can be utilized. And just to give it a better understanding, usually when we build a new application using these Duplos, we can get to prod in about a week. It allows us to focus on that special sauce that our application needs. We can collaborate across teams to build a better reporting experience. And this set of Duplos that we built actually are used in over 8 product areas in the company. So how do we build Duplos that are both useful and reusable? Because typically when you build a library, as it grows in size, usually the abstraction grows, and that's great for developers. But also, the flexibility becomes very difficult. Often we're tempted just to increase the surface area of our API, and no one wants to program to this, right? This is terrible. And what's really difficult is when you want to customize something deep within the core of the library, right? That's really difficult to access. So we need to look at a different way to customize, a different pattern. And it turns out we can just look at how Ember wires your app. Because as we know, Ember has so many has so much that comes out of the box. We're all rowing in the same direction because we have a common build system, config system, router, component library, and services. And we know that when Ember boots and runs our app, when a user lands on one of our routes, it's going to pull the correct route object, the correct controller object, the correct template, and render the component tree. And you might be wondering, how does Ember do it? I didn't have to wire that up. It just was done for me, right? While it may seem kind of magical, really it's a combination of both convention over configuration and dependency injection. Ember utilizes the dependency injection pattern, or DI pattern, to declare and instantiate classes/modules and the dependency between them. And ultimately, what this supports is this idea of the dependency inversion principle. If you haven't heard of that, to summarize, it says depend on abstractions, not concretions. If you look at a Lego, it has an interface, right? It has two interfaces here. It has a 1x2 interface and a 2x2 interface. And you don't know what I'm going to add to this Lego at all, right? It's a runtime concern. You might say, yeah, he was going to use a space Lego, right? He said he likes space. But you had no clue I was going to use this Google Eye one, right? So I want to take a deeper look into this, specifically when it comes to module lookup in Ember, as this will help as we move on. So if you ever built an Ember app and you built a module like a route, we usually build them in ES6 modules, right? But as Ed talked about, we're not actually using ES6 modules. If you look under the hood at like the Web Inspector, you'll see we have this define method in the string, and then we have our core logic, right? And that's because what our build system is doing is it's transpiling. Is that okay to say, Ed? Transpiling, right? ES6 modules into AMD modules, asynchronous module definitions. And so what it does is it takes our whole app tree and it gives each module an ID. And that ID typically looks like this. You have your prefix, which is the name of your app, followed by the module type. Here we have a route, followed by the name. And so when Ember goes to pull one of these modules, it'll go to the container and say, hey, I want this route. It's called bricks. It'll ask the registry, hey, do you have a registration for that? And if it doesn't, it says, hey, resolver, please resolve this for me. And it'll take that request and it'll translate that into a module ID, in which it'll go to the module registry and bring it back down and instantiate it. Now, I'm going to be honest. I'm hand-waving a few details here. There's a thing called a fallback registry, but in general, this is the flow that will happen in your app. And ultimately, this is how we bring add-ons into our system. When we have an add-on in our app, what our build system is doing is it's simply taking the two app trees and it's merging them together into a single namespace, and each of the components have a module ID, of course. And so when we want to bring in this add-on and this component, it simply goes through that same process that we just went through. And so we can utilize this concept of a single module registry and DI framework when it comes to customization of our Duplos. Because as we know, we can bring in add-ons into our app, and our app can depend on it, right? But what if I told you that you can bring your app into your add-on? So Ember apps can actually inject customization into add-ons so we can customize our Duplos. So now I want to look at a few patterns that my team uses to customize these Duplos. There's 4 of them. There's configuration, the provider pattern, the plugin pattern, and extend and replace. But to get started, we're going to make a quick demo app. We're going to make a data app, and we're going to use that same schema that I showed in the beginning. So this is like normal stuff. We just go and say Ember new. We're going to make an app called GoodBricks. I'm going to style it, give it a header, just a few bones here. And now we're going to install one of these Duplos, this ad hoc reporting experience called Nobby Reports. And to tell my app about Nobby Reports, I'm going to bring in this function that's going to mount all my routes to my application, as you can see here. And then this is going to, because we're bringing in this add-on, again, we're going to merge all the routes and controllers and services and models, everything that's in this Duplo in with my app. And now my app can use it. But we're not quite ready to launch our app. We have to configure it. So the great thing about Ember, it has a configuration story here. You can add configuration through the environment.js file. And add-ons actually have their own configuration file as well. And this is where you can put defaults that your host app can override. So if you've ever used this configuration object, you know that you can statically import it. It's usually under the namespace of your app. But what's a little bit tricky when it comes to add-ons is you don't know the name of the app, so you can't statically import it. So typically what you do is you do something at runtime with a dynamic lookup to the container. A lot of times my team uses this great add-on. It's called Ember Get Config. So then you can just simply add this static import, and it does all the lookups behind the scenes. So let's look at the default Nobby config. And there's 3 different type of config settings we have here. We have core settings. For instance, this tells Nobby which API to hit when it makes its request. We have refinements, and I know product owners really love this. This is like things where you could say, for my date range picker, I can say I want the last 7 days, or the last year, or the last 4 days. And so you can toggle and customize this to whatever your app needs. And then there's feature flags, of course. This is where you can turn on and turn off features that make sense for your app, or maybe you're just not ready to have them because you have a backend implementation that still needs to be finished. All right, so now we're going to configure our app. We're going to tell it about our API, and we're going to turn on a feature flag. And now Nobby can use this config object when it wants to make fetch requests and when it needs to make decisions whether or not to enable a feature. Another thing to consider is that configuration doesn't always have to be determined at build time, but sometimes it can be determined at runtime. I don't know if you have a lot of experience with configuration. I sure do. And I know that configuration can be a real beast. One of our applications has over 1,000 metrics. And to handwrite that and to keep that in sync with the API and the UI is a real tenuous and tedious task. And so what does every good UI developer do when faced with this difficult task? We just get the API team to do it for us, right? That's what they're there for. So what Nobby does is it simply asks the API, hey, what tables, dimensions, and metrics do you have? And it responds with a payload. And now we can teach Nobby about our schema, our tables, dimensions, and metrics. And now we can query it, which is pretty neat. So the next pattern is called providers. This allows an application to provide one of multiple implementations. So let's say I have this rocket ship, and I pull it off the shelf. It's pretty much complete, but it's missing something, right? It doesn't have any rockets. But it does have an interface. It has this 2x2 mounting interface. And so as a rocket developer, we can decide, hey, we want to use the Lego 3943 V2. So we can choose that one, or we might want the 4591. It's our choice. We're the rocket developer. And so we can do that same thing when it comes to Ember services. One thing that we noticed is that each application had its own opinions about sending notifications to the server. That little banner that says, hey, you did something really great, or hey, there's a problem. You might want to look into it. And so what Nobby does, it doesn't know about your app's opinions on this, but it simply relies on this interface, this abstraction called Nobby notifications. And this ultimately resolves to this module ID. And so we don't ship a notification service with Nobby, but we ship an interface. And this interface can be extended by the app developer to implement. And so we're going to go do that. We're going to simply generate the service, Nobby notifications, which is going to, of course, make the file. And ultimately, when that gets built, it's going to resolve to that same module ID. And so we could roll our own notification service, or we can just pull one off the shelf from the Ember add-on repo. So we can pull things like Ember CLI Flash, as seen here, or Ember CLI notifications. So let's do that. So we're going to implement our Flash notification service. We're going to extend that base one, and we're going to simply inject Ember CLI notifications, the one that's doing all the heavy lifting. And then we're just going to simply normalize the interface. So we do that for the add method and the clear messages. And so we can do this not only for just services, but we can do this for components as well. So another pattern we see is that each app seems to have its own icon pack. And it would be really annoying to have 2 icon packs because your bundle size, of course, would increase, but also just not consistent across the different experiences you may have. And so again, Nobby just relies on this component that it doesn't ship with, but it allows the app developer to provide. So we have here the icon being used in our template. Again, we can generate our own template at the app level, normalize the interface, and now we can use icon packs such as Denali. If you're not familiar with Denali, it's a new design language by Verizon Media. Or we can use the old standard font awesome. The other thing to keep in mind with all this is that these providers don't have to be sourced from the host app. If you find patterns, again, you're pulling the same providers, you can actually wrap them in an add-on and then provide that at build time. All right, next pattern is called the plugin pattern. Plugin patterns allow you to add additional functionality to your application. So let's consider a train, because a train has a plugin system, right? You can add different cars, maybe a sleeper car or a dining car, passenger car. And in Nobby, we do that same thing when it comes to visualizations. So we wouldn't be a very good analytics tool if we didn't have some great visualizations that come out of the box. And Nobby comes with quite a few, and each one of these visualizations has a way to display data. It has a way to select it, the visualization, and configure it. And so when it comes down to a good plugin system, it really is most effective when you can both easily register and discover new plugins. And as it turns out, we already have a great system for this because our AMD module registry knows all the things. It knows about every module in the system. We know how to register with it, right? We simply add a file to our app tree. The trick is knowing how to discover them. Now, this is a little controversial, but there is a way to find all the modules in your app. It's through this global called require. And I'm going to be honest, I don't love this interface, but you can actually get this prop called entries that has all the module IDs in the system. There is hope, though, to make a better interface. Now, this is a little bit of an older issue, but there is a desire to formalize this, which I really hope will happen. But as you can see here, in this module registry, we have all of our base core stock visualizations. And to discover them, we just have a service that will use that entries object and do something similar to what's called a class path scan in other technologies, and simply look via regex to filter out to get all the visualization objects. So let's make a custom visualization for our app. There's a few files involved because we have to persist the visualization. We have to configure all the different things I showed before. So we have a blueprint to generate all these files. And when we do, of course, the module registry knows about our new Lego bar chart out of the box. We didn't even have to implement it. It knows about it. So here's a quick demo of what this looks like. We have a report, and of course, we have some of our stock visualizations that our Duplo comes with. But now I'm going to apply a new set of visualizations. So not only do we have our bar chart visualization, but we have a Legoized one too. We have a pie chart and a Legoized one. I wouldn't say this is a great visualization, and it's pretty silly, but I think what it really illustrates the fact that this visualization would never make sense in the core Duplo, right? This is something that's totally a concern of the application. And so with this plugin system, we can add visualizations that totally make sense for the given application. All right, last pattern, extend and replace. This is where we replace default functionality with app-specific logic. So here's our rocket ship again. Yep, showing up. Let's say I don't like this rudder. It's just not working for me. I can simply remove it and add my own. There you go. And with Ember, we can do that. So here's a question. If I have an add-on with a component and it has a name brick card, and I have that same component in my local app, the same name brick card, who wins? Well, just like Wookiees always win, your host app will always win. It would make no sense for your add-on to be able to totally take over your application. Your application has to be in charge. And so we can utilize this functionality by extending and replacing stuff in our Duplo. So here is a table, and you guys are experts, right? You know what a metric is. So we have a metric called brick count. It counts all the bricks for the given part number. That's the dimension. And I don't know about you, but I haven't memorized all the Lego part numbers. So this isn't, the greatest experience. So what we can do is actually find out which component is responsible for rendering that part number. We can use the Ember Web Inspector to find out, as you can see here, and it resolves to this module ID. And so we're going to replace it. Again, we're going to go to our blueprint, use that same name. It's going to generate the file. It's going to generate that same module ID. And because the app always wins, this is the one that's going to go to the big show. So here, we're going to extend the component from the Duplo and add our new component. And we're going to have some special logic here. Again, this is like app-specific logic. We're going to say if the dimension is called part number, go and fetch an image and display it. And now, this is what we have. So here's our table, stock Nobby experience. Works for lots of people, but we can do better. So here we're going to apply our custom cell renderer. And now, not only do we see the part number, we see a picture of that brick. And this is a much better experience than we had before, right? All right. So if we look at all we've accomplished in a small amount of time, we had nothing. We brought in this Duplo. We configured it so it knows about our schema, our table, our dimensions, and metrics. We had opinions on our notification service and our icons. We extended it and added more custom visualizations. And we extended and replaced the default experience when it comes to the self-renderer. Now, I want to end with looking towards the future. I don't think anyone would disagree that the add-on ecosystem that we have today has been such a big win for our community. But I can't help to think, what would it look like if we had a Duplo ecosystem where we could pull off the shelf a config or an admin experience? We could have a chat client that we could just Ember install, or a message board experience that we can Ember install. And we can build applications with these larger abstractions, these larger pieces to get our app out to prod. While I think this totally works for my organization and scales well, I don't think we're quite there yet when it comes to the larger community. I think we need to think about a standard way to structure our apps even more than we have today. And also when it comes to styling, I think we'll definitely want to formalize the way we register and inject things. We might want to think about common state management and to really communicate contracts, think about bringing in type safety like TypeScript. Because ultimately, if you look at the trends of how we build software over the years, we used to write every lick of code ourselves. Then we went to a shared module and library system. Open source took off, and now we can pull in all kinds of libraries to build our apps. And now even hardware is being abstracted. And I think that this trend is going to continue. It's going to continue to the fact that we're going to start to see the rise of the citizen developer. This idea that people that use Excel today to build applications will be writing code and software to get their job done. And ultimately, I can't think of a better framework that cares more about great tooling, ergonomics, and the first-time developer than Ember.js. Thank you.